Good morning, Year 9. Today we are going to continue our work on area, but today we'll be looking at parallelograms and trapeziums. Now, at certain intervals throughout this video, I will give you a prompt to go and do one of the tasks that have been set. It's completely up to you whether you want to watch the whole video and then go away and do the tasks, or whether you want to follow my prompts and go do the tasks when I recommend to do so. I would strongly recommend that you do follow the prompts, only because it breaks down into a much better structure and it might help you out. But if you'd like to do all the tasks at once, again, I don't have a problem with that. Okay, so to start with, we're going to start with parallelograms. Now, to work out the area of a parallelogram, I want to just bring your attention back to, if I can just change the color really quick, change to black. Back to the idea that we were talking about last time, where to work out the area of a shape, we have to do height times width, but we have to make sure that the height and the width are perpendicular to each other, so they meet at a right angle. Now, looking at this shape straight away, it's not easy to tell where this perpendicular height and width might be. But if I was to just move this along slightly with my amazing animations, you can see that if you cut off the triangle that was here just a second ago, we've now moved it over here. And as you can see, this actually does form a rectangle. So because of this, we can just do the vertical height here. 1, 2, 3, 4. We'll pull that 4 centimeters again. And the horizontal width here. So that's 1, 2, 3, 4, 5, 6, 7. So that's 7 there. So to work out the area of a parallelogram, again, we have to find the perpendicular height and width. So in this case, that is 4 times 7, which gives us 28 centimeters squared. Okay, so if we move on to look at another example, so for this one, as we've just proven, all we need is our perpendicular height and width. So in this case, we can find the perpendicular height as the height that runs up this way. Again, so that's 1, 2, 3, 4, 5. That's 5. I'm going to call that meters this time. And the width down here, 1, 2, 3, 4. So that's 4 meters down here. So for this one, we do 5 times by 4, which will give us 20 meters squared. Again, remember we're keeping an eye on the units. So here we've marked that these are meters. So we keep that in meters squared. But remember that in each question that might change. It could be meters, centimeters, millimeters, kilometers, who knows? But the question will let us know. Okay. Looking at another one. This is still a parallelogram, but it's slightly different as it's on its side. So once again, we need to find our perpendicular height and width. Now this one's a little bit different because it's given us 3 different totals of different heights and widths. I just want to bring your attention to these two to start with. So here we have 11.2 and 5.2. These are definitely the first ones you need to look out for, because as we can see here, they meet perpendicularly. So we know that these two are the ones we need to use. This value here has been put there as a kind of trick. It wants to trick you. It wants you to do 11.2 times 5.9 or 5.2 times 5.9, whereas actually that value is irrelevant to us at the minute, because all we do is if we imagine that this triangle here gets moved over to here, that would create our new rectangle, wouldn't it? So that proves that we need to do 11.2 times by 5.2, which would give us, I'm cheating and using a calculator because this is allowed, as we can see in this top corner here, which will give us 58.24. centimeters squared. I'll sneak that in down there, centimeters squared. Right. Okay, so next we'll be moving on to trapeziums. So I would suggest at this point you pause the video, go and attempt task 1, which is all about parallelograms. And then once you've done that, come back and pause the video. If not, feel free to carry on with the video and we'll go through trapeziums and then we can move on to the tasks at the end. So I'll pause just for a second. Okay, brilliant. Welcome back, anybody who went away to do the task. So here we're going to talk about trapeziums. Now I've put the formula for the area of trapezium down here, which is a plus b, which we can see is this top length here at this bottom length here, times by half of the height. So half of this height going up here. Now the reason that we can use that formula for this is that if I was to cut this in half like that, again, look at these amazing animations, then we'd end up with, we'd have halved the height because we've cut it in half vertically. A is now down here and B is here. But then if I flip that one, slot it in next to it, what we can see now is what we've actually created is a parallelogram. Because if I was to cut that little triangle off there and put it on the end here, we'd make a rectangle. So because we've turned this into a parallelogram, and as we've just spoke about with the last one, we now have our perpendicular height and width. So because we've halved it, we can do half height and A plus B. So our formula for working this out is again A plus B multiplied by half of the height. Okay. So moving on to an actual example of one. As we've just proven, if we imagine that we'd cut this in half, move this one over here, and then flipped it, we'd end up with a parallelogram, wouldn't we? But we don't need to waste our time doing that when we can just take our A and B. So we'd say that A equals 9, B equals 15. Again, it doesn't matter which way around A and B really are because we're just going to add them together, so they could be either way around. And then our height is 4. So as we remember, the formula for the area of a trapezium is A plus B multiplied by half of the height. So in this case, that is 9 plus 15 times by half of 2 being our height. So what that gives us is 9 add 15 gives us 24. So that's 24, that should have been a 4, times by half of 4. 24 times by 2, which gives us 48 centimeters squared. Okay. On to the next one. Again, this is a trapezium, but it looks slightly different. This is just a trapezium on its side. So we've got to imagine that this is the base, this is the top, and these are either sides. So it would really, if we wanted to draw it how we would like to see it, it would look something like this. Cool. And don't worry too much that this doesn't have a little triangle on the end of it, because remember, again, with a trapezium, we just cut that in half, move that down here, and flip it. That's how we prove that our formula works, and they still would slot together to make a rectangle, wouldn't they? So that proves that the formula still works. So in this case, A would be here, B would be here, and the height, instead of being in the middle here, we can see that it's down the outside because that is a right angle here. So that proves our perpendicular height and width, because our perpendicular height is now 4. So we can label that as H. So again, the formula for the area of a trapezium is A plus B times by half the height. So again, we've got our A, which is 8, plus B, which is 11, multiplied by half multiplied by our height, which is 4 again. So we can rewrite that to be 19 times by a half times by 4, which is the same as 19 times by 2, which will give us 38, which means that the area for this trapezium is 38 centimeters squared. Brilliant. Just a final one to look at. Normal trapezium, just how we'd like to see it, because we'd recognize that straight away. But the difference in this one is that it tells us what the area is, and it wants us to work out the length of one of these sides. But it doesn't change how we start. We can still label all our sides. So then we'll label that A, we'll label that B, and that is obviously our height. And it says that the area equals 34 centimeters squared. So what that means, if we rewrite our formula, we know that A is 6, so we can do 6, add B in this case, but I'm going to keep it as X because it wants me to find the value of X. It just saves me swapping them out. Multiplied by half height, which in this case is 4, so that would be 2. So multiplied by 2 equals 34 centimeters squared. So the first thing we can do is, if we remember our rearranging, we can multiply everything by 2, which will remove the 2 from this side. So that'll leave us with 6 plus x, or divide everything by 2, sorry, I should say. 6 plus x equals, and again, we've divided everything by 2, so this side is divided by 2, so we just need to divide this side by 2, which would give us 17. So it means that 6 add x equals 17. So then we need to, I'm just going to label that really quick actually, so that we all know what we've done. We've divided by 2. Here, we're going to take away 6, and that leaves us with x equals 11. So this value here must be 11 centimeters. Okay then, at this point, I would suggest that you go away and do task 2, because that is all about trapeziums. But again, if you want to carry on with the video while we have a look at some more compound shapes, that's absolutely fine. Okay, so the next one here is we have a compound shape. And again, a compound shape is just two shapes joined together, isn't it? So it says, shown is a plan of a small field, and we want to find the area of this small field. So looking at this straight away, I wouldn't have the first idea how to solve this to find the area, because this shape, I don't know how to work out this shape. So what I have to do is I have to break it up into two different shapes that I do know how to do. So if I put a line across here, I've split this up into a rectangle and a trapezium. And rectangles we covered in the last lesson, and trapeziums we've just covered now. So we know how to figure out both of them. So all we need to do is figure out the area for each individual shape and add them together. Let's start with the rectangle because it's nice and easy. So if I label that the rectangle, underline it, we've got our, again, we need our perpendicular height and length, width, sorry. We always need our perpendicular height and width to find the area of anything. So to start with, we've got 11 as our height. Multiply that by 14, and we get 154. So the area for the rectangle is 154, almost used the wrong units there, meters squared. Next, we have our trapezium. Underline that. And again, formula is A plus B multiplied by half the height. So we've got our trapezium here, but the problem is it's upside down, isn't it? It's upside down from where we'd want to see it. So I'm going to go ahead and draw it out. So first I'm going to start with this side. So we'll draw this side. Next I'm going to do this side. Draw it out that way. I'm going to do this imaginary side that we've put in here. So I'm going to put that across here. And then finally this bit here. There we go. Now my one's not quite to scale with this. Well, I mean, none of it's to scale because that's definitely not 20 meters, is it? But it's good enough for me to visualize what I'm doing. So first of all, I'll label the side that I know. I know that this side here is 20 meters. So I can label that 20 meters. This side here, we don't know just by looking at it, but we can figure it out because we know that this side all the way up here is 18 and this bit here is 11. So if we take this part away from this whole length here, so we do 18 minus 11, that leaves us with 7. So this length here must be 7 meters. The next part we can figure out is this imaginary line we've put here, because this width must be the same as this width here, mustn't it? Because these sides only go as far out as the same bit here. So we know that we can label this 14 meters. And we don't need this length here. I'm going to put a question mark just because we don't know. But we don't need it to figure out the area, do we? Because we've got everything we need here. We've got our A, we've got our B, and this can be our height. So we can rewrite this as A, or 14, add B, which is 20, multiplied by half, multiplied by the height, which is 7. So if I simplify this a little bit, we've got 14 add 20, which is 34. So we'll do 34 times a half times by 7. Again, I'll just half the 34. So we got 34, which is 17. So then we do 17 times by 7, which gives us 119. So that's 119 meters squared. So we have our area of our trapezium. We have the area of our rectangle. So all we need to do now is add those together. So we do 119, add 154, which gives us 273. So the area of this whole compound shape is 273 meters squared. Okay, so once we've done this, I would suggest you move on to task 3, which is compound shapes. All the shapes on there we've covered in these last 2 lessons. The only skill that really is a new one is being able to recognize where those shapes are and just do it shape by shape. So if there's squares in there, work out the squares. Trapeziums, work out the trapeziums. Parallelograms, work out the parallelograms. All the shapes we know, and then we have to make the decision whether we need to add them together or some questions may ask us to take them away. Now, different to our lesson yesterday, I will be available on Teams throughout the entire time slot that we would usually have our lesson. Please feel free to jump on and ask me any questions you've got. But if not, good luck, and we will have a live lesson later on in the week. Okay, thanks very much, guys.